Welcome back, Mathcounts friends. Yesterday they released the chapter competition for Mathcounts, and we went over the sprint round in a couple of videos yesterday. So today we're going to tackle the target round, and let's go ahead and dive right in. So first one here says, while practicing for Mathcounts, Eli attempted to add the first 10 positive integers, accidentally left one out, and ended up with a perfect square. Which number did Eli leave out? Okay, so if you've ever added up the first 10 positive integers before, you will know that it gives you a result of 55. If you didn't remember that off the top of your head, you could just think about, well, you could either just add them up, or you could remember that when you add up consecutive integers in an arithmetic series, you can just take the first number, I call that the starting number, add the ending number, and divide by 2. That gives you the average value as long as it's an arithmetic series. And then you have to multiply by the number of numbers. So in this case, the starting number is 1, the ending number is 10. You divide that by 2, and you multiply by the number of numbers, which is 10. So that gives you 11 times 10, which is 110, divided by 2 is 55. So 55 is what he would have gotten if he had not left one out. And we know that because he left one out, he ended up with a perfect square. So what's the next lower perfect square from 55? Well, it's 49. And so in order for him to have gotten 49 by leaving out one number, that number would have to be 6, because that's the difference between those two. So the answer here is that he left out the number 6. All right, let's go ahead and move on to number 2. This one says, an isosceles trapezoid has bases of length 15 inches and 21 inches and a height of 4 inches. Okay, so 15 inches and 21 are the bases, and then 4 inches is the height. What is the perimeter of this trapezoid? Okay, so one thing that's important is we're going to need to find these diagonal lengths here. And because we know it's an isosceles trapezoid, that means that these angles are the same here. So these two triangles that we have on the ends here, they should be the same. They should be congruent. So the hypotenuses should be the same. And if you look at the difference between the larger base and the smaller base, that's 6. And since it's symmetric, three of that distance is going to have to be over here, and the other 3 is going to have to be over here. So we have a 3, 4, 5 triangle, which should be familiar to you. You can find the hypotenuse using the Pythagorean theorem if you don't happen to remember that. But that's the classic classic Pythagorean triple right there, 3, 4, 5. So in order to find the perimeter, we have to add up all the lengths of the sides, which we have all those lengths now. So 5 and 15 and 5, those 3 will add up to 25. And then down here at the bottom, we have another 21. And if we add those together, we'll get our final answer, which is 46. Okay, let's go ahead and move on to number 3. This one says two perpendicular lines intersect at point 25. They've got that graphed for you here. It says well, they've got one of the lines graphed at least, and that intersection point. It says if the y-intercept of one of the lines is 7, that's this one here, then what is the y-intercept of the other line? Okay, so we know that the other line is perpendicular because it says they're two perpendicular lines. It looks like the slope of the one that's drawn is -1 because every time it goes over, it goes down 1. So the slope of the other one is going to be +1 because the slope of a perpendicular line is the negative reciprocal of the slope. So if we have -1 for the slope, then we need to take the negative reciprocal. So that's -1 divided by -1, which is equal to 1. So our slope of this other line is going to be 1, and we know that it intersects at that point 25. So we can just trace it back and find that the other y-intercept is going to be 3. So the answer to problem 3 is 3. All right. Let's see. Amanda is thinking of a positive integer. This is number 4. The sum of the distinct prime factors of her integer is 10. And her integer is less than 100. What is the sum of the possible values of Amanda's integer? Okay, so how can we get distinct prime factors that are going to add up to 10? Well, let's see, 10 is even. So if we have a 2 in there, um, let's see, I guess we would need two odds to make it even. Is that going to work? So we could put 2, 3, and 5. Yeah, that works. The smallest 3 primes, they do add up to 10, right? That gives you 10. Um, and but if we want to have 2 odds, a different 2 odds with 2, that's going to be too big. So we can't have 2 from now on. What about 3? So in order to get from 3 up to 10, we're going to need 7, which is prime. So that's another way to do it. That'll get us up to 10. And those are the only 2 ways, because once you go up to 5, that'll be another 5, but then it wouldn't be a distinct prime factor. So those are the 2 ways to get distinct prime factors that add up to 10. So you can multiply these together, but you'll have to consider all the different powers, or all the different exponents that you can put on these. You can't use an exponent of 0 because these are prime factors, so it has to be 1 or greater. So we can start. Let's start with this one here, and let's just do 2 times 3 times 5, right? So that's going to give us 30, and then we can add another power of 2. So if I say, well, so if I look at the exponents, we had 1, 1, 1 for these exponents, that gave us 30. And if I do 2, 1, 1, that's going to give us 60. And if I do 3, 1, 1, that's going to give us, let's see, am I doing this right? Let's see, that'll be 8. No, did I do that? Yeah, so that'll be 8 times 15. That's going to be too big, isn't it? Because we need it to be less than 100. Okay, so that's not going to work. Now what if we do 1, 2, 1 for the exponents? So that'll be 10 times 9. That'll give us 90. And of course, we can't go any bigger there. What about 1, 1, 2? That's going to give us, let's see, 25 times 6. That's going to be too big. All right. And could we do 2, 2, 1? Let's see, that'll be 9 times 4 is 36 times 5. No, that's going to be too big. So these are all the ones. Let's see, we have 3 of these based on using the primes 2, 3, and 5. What about the primes 3 and 7? So 3 times 7, that's going to give us 21. That's with the exponents being 1 and 1. I didn't write the 20. 21. And then if we do 2 and 1, that'll be 9 times 7. That'll give us 63. And if we use anything bigger than that, or if we do 1, 2, that's not going to work. So if we do 3, 1, that's not going to work. If we do 1, 2, that's not going to work. So these are the 2 possibilities using these 2 prime factors. Now we've got all the answers, and what does it want? It wants the sum of them all. So we have to add them all up. So here we have 90 and 90 is 180 for these 3, and this is 84 over here. So 180 plus 84, that'll be 264. Let's go ahead and write that here. 264. That's our final answer there. Okay, moving right along. Let's go on to number 5. You'll notice that, let's see, on these last couple problems I've been switching it so that it's white lettering on a black background. Let me know in the comments if you like that style better than what I've been doing up till now with the black on white. All right, it says how many integers x satisfy this inequality here? Okay, so what does this inequality mean? It means that x is within 6 of -2. So, for example, if x is equal to -2, then that absolute difference, or the absolute value of that sum, I should say, will be 0. And so as long as x is somewhere close to -2, then this thing is going to be satisfied. And you can go up by 6 or down by 6. And if you count all those integers, that'll go all the way from -8, which is down by 6, right? And if we go up by 6, then we're going to get up to 4. X equals 4. Oops. Let's see, I guess I didn't write x. I just put 4 there. So all the way from -8 up to 4. How many integers is that? Well, it's 13. You've got to be careful not to make an off by 1 error there. You can't just subtract these two because there are 6 above -2, 6 below -2, and there's -2 itself. So there are 13 integers. That's the answer there. Let's go on to number 6. What is the sum of the three smallest positive integers that are both a multiple of 5 and also one more than a multiple of 7? Okay, so we can start thinking about numbers that are one more than a multiple of 7. Now, that's going to help us get through the numbers quicker than if we start looking at multiples of 5. So the first one is 8. That is one more than a multiple of 7, but it's not a multiple. Well, I guess the first one is actually 1, right? Because 0 is a multiple of 7. So 1 is not a multiple of 5. 8 is not a multiple of 5. The next one is 15, which is a multiple of 5. So that's our first, that's our very smallest positive integer. But we need the three smallest positive integers. So we need to find two more. And because 5 and 7 are relatively prime, in order to get a number that has the same mods, in other words, it's also one more than a multiple of 7 and also a multiple of 5, we're going to have to add the product of 5 and 7. So we're going to have to add 35 to 15. That's going to get us up to 50. We can, if we want, we can double check that this is one more than a multiple of 7 because 49 is a multiple of 7 and it's also a multiple of 5. And then we can add 35 again, and that's going to be, let's see, so that's going to be 85, right? And then what do we want? We want the sum of those? Yeah, the sum of those. Okay, so when you have a sum of a linear series like this, you can just take the middle number, or the median, I guess, and multiply by the number of numbers. So that's going to be 50 times 3, which is 150. So that's our answer here. Yeah, so if the reason we could go up by 35 was because 5 and 7 were relatively prime. If 5 and 7 were not relatively prime, you'd have to like divide by I guess the greatest common factor and then increment by that amount. Okay, so let's go on to number 7. This one says a triangular number is a positive integer of the form 1 plus 2 plus 3 plus ... up to n. For some positive integer n. What is this positive difference between the 8th triangular number and the 6th triangular number? Okay, well, so the 6th triangular number is just going to be plus 4, plus 5, plus 6. That sum is going to be the 6th triangular number. And the 8th triangular number is just going to have two more terms added on, right? So it's going to have a plus 7 here and a plus 8 here. And the difference between those two is just these two terms here, which is, if you add those up, it's just 15. So that was a pretty simple one. The reason it was that number 7 was easy in this target round is because number 8 was very difficult. In fact, I made a special video just for number 8. This is number 8. I'm not going to go through the solution in this video. I'm going to have you guys watch the other video. It's a YouTube short. It's the first time I've done that, but I hope you'll enjoy it. I think it's a lot of fun. This was a very difficult problem at my chapter competition. Nobody got this question right. And I'll give you kind of well, let's at least read the problem first, I guess. It says an equilateral triangle has one vertex on the positive x-axis, one vertex on the positive y-axis, and one vertex at 2025. They always love to put the year in these problems, right? So 2025. What is the area of the triangle in square units? Express your answer as a decimal to the nearest hundredth. Okay, so in the target you have a calculator, which is good for this problem. None of those other ones we needed a calculator, I guess, but this one you do. And I'll just draw it out for you here. This is what the problem looks like when you sketch it out. And I'm going to give you guys a little hint. If you don't want to see the hint, you can sign off right now. I'm going to show you the hint in a couple seconds. But thanks for joining the video, everyone. Hope you guys enjoyed it. Please like and subscribe. And don't forget to check out the short video, which will be linked up here somewhere, that goes through problem number 8. And here is the hint. So feel free to take a look at that and try to figure out on your own before you click on this video. And we'll see you guys next time.